In this lesson, we will discuss the concept of related rates. The rate of change of one variable related to the rate of change of another variable. And in here, the rate of change will be with relation to time, the rate of change with respect to time. Now, consider, for example, the function we looked at in the beginning of this course. A student assistant earns $7.5 an hour. What is the amount of money that he takes home as a function of the number of hours? We said we can write it as A equal to 7.5t, where A is the amount of money, T is the number of hours. Now, T changes, A also changes. Is that right? Well, both changes with respect to time. So, what is the rate of change of A with respect to T, the time? Is dA by dt. Now, find the derivative of both sides of this equation with respect to t. We find dA by dt equal to 7.5. What's the derivative of t with respect to t? Is dt over dt, or it is 1. Or we find that dA by dt is related to dt by dt. Related rates. The rate of change of one variable is related to the rate of change of another variable. We have dA by dt is 7.5. Now, this is a very simple example. Now, what is another example we can think of around us that can be used to explain this phenomenon of related rates? Now, imagine that you are blowing a balloon. Now, what is happening there? The volume of the balloon is increasing with time. As time increases, the volume increases. Now, how many of you know the equation for the volume of a sphere? When the balloon is inflated, it is a sphere, is that right? What is the equation for volume of a sphere? Well, volume of a sphere depends on its radius, is that right? I can write V equal to 4/3 pi r cube. The volume of a sphere depends on its radius. Now, if I draw it as a circle, well, the only way you can draw the cross-section of a sphere is as a circle, is that right? That's the radius. Now, you notice that as radius increases, the volume also increases. Now, the rate at which the volume increases, that means the rate of change of volume with respect to time, depends on the rate at which the radius changes. Is that right? Yes. Now, in other words, suppose we say radius changes, say, 1 centimeter per second. Now, how do I write it? I say dr by dt is 1 centimeter per second. That is the rate at which the radius changes. That means after 1 second, that is our balloon. This is the increase in radius in the first second. And look at the increase in volume. Now, after another second, the radius again increases by 1 centimeter. And that is the new increase in volume. Now, look at this and tell me. When radius increases by 1 centimeter each time, is the increase in volume is the same in both cases? No. The increase in volume keeps on increasing. In other words, as the rate at which the radius increases 1 centimeter per second, each second, the increase in volume is greater and greater and greater. The rate of change of volume depends on the radius, also it depends on the rate at which the volume changes. Alright, now how do we represent this? Remember that both volume and radius are changing with time. So what we do is we find the derivative of the left hand side and right hand side with respect to time. Now, what is the derivative of v with respect to time t? It will be dv over dt. So I can say dv over dt equal to, can you find the derivative of the right hand side with respect to t, the time? Remember, 4/3 pi is a constant, so that will remain as it is. That will be 4/3 pi times, what is the derivative of r cubed with respect to t? Well, that's something that we have been doing in the past couple of lessons. The derivative of r cubed with respect to r is 3r squared. The derivative of r cubed with respect to t is 3r squared dr by dt. That means if you want to find the rate at which the volume changes, you need to know at a particular instant what is the value of r and what is the value of the rate at which the radius changes. Only if you know these two things, we can find the rate at which the volume changes. So this is the kind of situation we are looking at in what we call related rates. The rate of change of one variable is connected to the rate of change of another variable, and the rate of change is always with respect to time in this case. Let's do a quick review of what we already talked about, or what you already know. What is the derivative of, or d by dt of, say, r squared? What is the derivative of r squared with respect to time? It will be 2r dr by dt. Alright? What is d by dt of, let's say, x squared? What is d by dt of x squared? Derivative of x squared with respect to time t will be 2x dx over dt. Another one. What is d by dt of y to the power of 4? Well, that will be 4y cubed dy by dt. One more. What is d by dt of sine theta? Well, you can see if a searchlight is moving, you can see the angle will be changing with time. Is that right? And in such problems, we need to know how to find the rate of change of sine theta with respect to time. How do we do that? Well, the derivative of sine theta is cos theta. But the derivative of sine theta with respect to theta is cos theta. The derivative of sine theta with respect to t will be cos theta times d theta by dt. The rate of change of theta with respect to t. The derivative of sine theta with respect to t is cos theta times the derivative of theta with respect to time. Right? The derivative of tan u with respect to time will be secant squared u times du by dt. You must be very familiar with this in order to do problems in this section. Alright, let's look at this problem. Find dy by dt for x squared plus y squared equal to 25. Given these informations, the informations given are, we need to find dy by dt when x equal to 3, y equal to 4, and dx by dt equal to 8. Now remember, we are finding the rate of change of y with respect to time. And at a particular instance, when all these given values are there, we need to find dy by dt. Now to do that, all we need to do is take our given expression and find the derivative of each term with respect to time. So we find the derivative of x squared with respect to time, find the derivative of y squared with respect to time, and the derivative of 25 with respect to time. Alright, tell me, what is the derivative of x squared with respect to time? It will be 2x dx over dt plus, what is the derivative of y squared with respect to time? Will be 2y dy by dt equal to, what is the derivative of a constant 25 with respect to time? Derivative of a constant with respect to any variable is 0. So that will be 0. Now, we need to find dy by dt. And we know x, we know dx by dt, we know y. So all we now need to do is solve for dy by dt. So we can say 2y dy by dt equal to, move that term to the right side, negative 2x dx by dt. Well, that means to find dy by dt, we divide both sides by 2y. Therefore, dy by dt equal to negative 2x divided by 2y times dx over dt. Well, of course, 2 and 2 goes. We have all these values. Let's replace all those values. That will be negative x over y. X is 3, y equal to 4. Negative 3 over 4 times dx by dt is 8. And what's that equal to? That will be negative 6. The value of dy by dt is negative 6. At the instant when dx by dt is 8, x equal to 3, and y equal to 4. What does that mean? What is the physical meaning of that? When you say dy by dt equal to negative 6, it means y is decreasing with time. When x is increasing with time, y is decreasing with time. That's the meaning in there. Alright, look at this problem. A point is moving along the graph of y equal to sine x, along the graph of y equal to sine x. Find dy by dt when x equal to pi by 6 and dx by dt equal to 2 per second. 2 radian per second. Now, any problem, you need to visualize it. What is the graph of y equal to sine x? Now, we got y along the horizontal axis and x along the vertical axis. If you have a pi by 6, say pi by 3, and so on, the graph of y equal to sine x will be something like this. Is that right? Sine of 0 is 0, sine of pi by 2, if this is pi by 2, sine of pi by 2 is 1, sine pi is 0, and so on. Well, we are given that x equal to pi by 6, so the point is over here at x equal to pi by 2. We need to find the rate at which the y changes. You can see as the point moves along, y changes and also x changes. Now, we are given the rate at which x changes. We need to find the rate at which y changes at that point. Well, what do? The usual thing, we write down the function and find the derivative of each term with respect to time. Alright, let's do that. We got y equal to sine x. Find the derivative of each term with respect to t, the time. What is the derivative of y with respect to t? It is dy by dt equal to, what is the derivative of sine x with respect to t? Don't confuse again. The derivative of sine x with respect to x is cos x. The derivative of sine x with respect to t will be cos x times the derivative of x with respect to time, cos x dx by dt. Now, we need to find dy by dt when x equal to pi by 6 and dx by dt is 2 centimeter per second or radian per second. Now, so substitute the given values. X equal to pi by 6. So that will be cos of pi by 6 times dx by dt is 2. What is the value of cos pi by 6? Cos pi by 6. Well, several times, in fact, last lesson we talked about it. Cos of 0 is 1. Cos of pi by 6 is 30 degrees. Is square root 3 over 2. Cos of pi by 4, 45 degrees, is square root 2 over 2. Cos of pi by 3, 60 degrees, is 1/2. Cos of pi by 2 is 0. So cos of pi by 6 is square root 3 over 2 times that 2. And so dy by dt equal to square root 3 centimeter per second. Centimeter per second. Centimeter divided by second. When dx by dt is 2 and x equal to pi by 6. When you read a problem, you need to form a picture of it in your mind. The radius of a sphere is increasing at the rate of 2 centimeter per minute. Find the rate of change of its volume. As the radius increases, the volume increases. At the instant when r equal to 6 centimeter. Remember, the rate of change of volume, as I explained to you earlier, will change with the value of the radius. As the radius increases, the rate at which the volume increases will change. So we need to find the rate at which the volume increases at the instant when r equal to 6 centimeter. So tell me, what is it that we are looking for? Find its rate of change of volume We are looking for dV by dt, the rate of change of volume with respect to time. What do we know? What are the known things? Let's write down the known things. First of all, we said the radius of a sphere is increasing at the rate of 2 centimeters per minute. How do you write that down? What is that? The radius is changing at the rate of 2 centimeters per minute. It means dr by dt equal to 2 centimeters per minute. Now look at the way I'm writing it. I'm writing it like this. 2 centimeters per minute. Minute belongs to the denominator. Alright, so dr by dt is given to be 2 centimeters per minute. And the value of r is given as 6 centimeters. We need to find dV by dt. Alright, so you know the given things. How do you proceed? What's the method? Well, the method is, because we want to find the rate of change of volume, and the volume is related to radius, we need to write down the equation for the volume of the sphere. And we started with that in the beginning of the lesson. What is the equation for volume of a sphere? These are some of the things a calculus student must quickly have. Must be at the tip of your finger, is that right? Volume of a sphere, the surface area of a sphere, those are the things we use very often. So, volume of a sphere V equal to 4/3 pi r cubed. And now what do? We have the equation. We want to find dV by dt when dr by dt is given at the instant when r equal to 6 centimeters. So what we need to do is find the derivative of both sides with respect to time. So what is the derivative of v with respect to time? It is dV by dt, that's what we want. Will be, what is the derivative of the right hand side? As we talked about it earlier, 4/3 pi is a constant. Now, the derivative of r cubed with respect to t is 3r squared times dr by dt. Now, here 3 and 3 goes, and that gives you 4 pi r squared dr by dt. dV by dt equal to 4 pi r squared dr by dt. What is left for us to do is simply bring the known values. dr by dt is known, r is known, so that will be 4 pi times r is 6 squared times dr by dt is 2 centimeters per minute. And what does that give you? That will be 6 squared is 36. 36 times 2 is 72. 72 times 4 is that 288? 288 pi centimeter per minute. That is the rate of change of volume with respect to time at the instant when the radius is changing and at that value of the radius. Now, there's a small error in here, what I said. Did anybody spot it? Well, if you noticed, the unit of measure, this is radius is 6 centimeters square. So there is a 6 centimeter there. That will be centimeter squared. Centimeter squared times centimeter is centimeter cubed. So the rate at which the volume increases is 288 pi centimeter cube per minute, not centimeter per minute. Volume, the unit of volume is centimeter cube. Now, before we go any further, I want you to stop the video and do a couple of problems on your own. Make sure that you understand these concepts. So, given that y equal to square root of x, find dy by dt when x equal to 4 and dx by dt equal to 1.5. Now, keep in mind that the derivative of a square root quantity is 1 over 2 square root quantity times the derivative of that quantity. So tell me, what is the derivative of square root x with respect to t? It will be 1 over 2 square root x times dx by dt. All right, now I've given you the answer. Check with it and make sure that you do that well. Next one, given that x squared plus y squared equal to 4, find dx by dt when x equal to 4, y equal to 3, and dy by dt is negative 2. And the answer is 1.5. All right, do this before we start with a couple of problems again. All right, let's try this problem. An airplane is flying at an altitude of 8 kilometers and passes directly over a radar antenna. When the plane is 15 kilometers away, the radar detects that its distance is changing at the rate of 400 kilometers per hour. What is the speed of the plane? Well, as I said earlier, in order to do a problem, the first thing to do is to picture the problem. First of all, you need to picture the radar station, and the plane is flying, well, towards the station. Well, of course, at an altitude of 8 kilometers. Now, the distance between the radar and the plane is changing. Is that right? And the rate of change of that is given. We need to find the speed of the plane. Now, can you draw a diagram and look at some of the given things and figure out what are we looking for? Well, I have a diagram here. This is the radar station. That is the plane. With apologies, that's all I could do with my Word document. Now, the plane is flying in a straight line here. That's the distance x there. And so, the speed of the plane is the rate at which x is changing, or dx by dt. Now, we need to find the speed of the plane, means we want to find the rate at which x is changing. We want to find dx by dt. Now, the distance of the radar station from the plane is this distance. I call it s. Now, the rate at which s changes is given to us. What is that? Now, s changes at 400 kilometers per hour when s equal to 15 kilometers. When this s equal to 15 kilometers, that is changing at the rate of 400 kilometers per hour. It's very important. So you got to write that down. When s equal to 15 kilometers, ds by dt is 400 kilometers per hour. And at that instant, we need to find dx by dt. Well, you notice at the diagram that there is something in geometry that establishes relation between x and s. We know we need to find dx by dt at the instant when the value of this s is 15 kilometers and the rate of change of s with respect to time is 400 kilometers per hour. Right? So in order to find that dx by dt, we need to establish a relation between s and x. All right, can you write down a relation? Do that on your own. What is the relation that connects x and s? Well, of course, this is a right triangle. And this side remains a constant. Is that right? It doesn't change. So h squared plus x squared equal to s squared is the relation. So I have done some writing there. The distance of the plane from the radar is s. The vertical distance of the plane from the radar, that distance is 8 kilometers. That remains a constant. It does not change. The horizontal distance of the plane, so this is vertically above the radar station. That horizontal distance is x. And the rate at which that x changes is the speed of the plane. The speed of the plane, therefore, is dx by dt. And we know that at the instant when s equal to 15 kilometer, the value of ds by dt is 400 kilometer per hour. So ds by dt is 400 kilometer per hour. And we are looking for dx by dt. And I just asked you, write a relation connecting s and x. And I just gave it to you. What is our relation? S squared equal to x squared plus 8 squared, because these are the sides of a right triangle. So s squared equal to s squared, x squared plus 8 squared. And what all now you need to do is to find the derivative of each term with respect to t, the time. All right, let's do that. S squared equal to x squared plus 8 squared. And find the derivative of each term. What is the derivative of s squared with respect to t? The derivative of s squared with respect to t is 2s ds by dt. The derivative of x squared with respect to t is 2x dx by dt. And the derivative of 8 squared with respect to t is 0. Right. So d by dt of s squared equal to d by dt of x squared plus d by dt of 8 squared. Now, this is 2s ds by dt equal to 2x dx by dt plus 0. We need to find dx by dt, and we know the value of ds by dt. We know s, but we don't know this x. What do? Well, if you go back to our diagram, in this relation, s squared equal to x squared plus 8 squared, when s equal to 15, see, remember, we want to find dx by dt when s equal to 15. All right, go back to that equation and replace s by 15 and find the value of x. And that will be the x value that will go in there. So that's something that you need to be careful about. So we solve for dx by dt. What do you get? Dx by dt equal to s over x times ds by dt. Now, as I said, we know the value of s. We know the value of ds by dt. We need to find the value of x in order to find the value of dx by dt. How do we do that? Go back to that equation. All right. In s squared equal to x squared plus 8 squared, we find x when s equal to 15. So we got 15 squared equal to x squared plus 8 squared. And that simplification is easy for you. That will give you x equal to square root of 161. And now bring all those values into that equation. We now use the values of s, x and ds over dt to find dx over dt. So dx over dt is s over x dx by dt. S is 15, x equal to square root of 161, and ds by dt is 400, and that gives you dx by dt, the speed of the plane, is 473 kilometer per hour. You can see these problems are very much things that we see around us. So a lot of these applications are very much part of our daily life. Okay, let's look at another problem. Well, as you see, the projector has a rolling problem, and that may be a little disturbing when you watch it. But try and concentrate on the problem and try to ignore that as much as possible. The problem is a ladder 8 meters long is leaning against the wall of a house. The base of the ladder is pulled away from the wall and at the rate of 0.6 meters per second. Find the rate at which the angle between the ladder and the wall changes. Now, if my hand is the wall, this is the ladder, as the base gets pulled away, you can see as the base gets pulled away, the angle between the wall and the ladder changes. So, as the rate at which the base is pulled away is given, you need to find the rate at which the angle between the ladder and the wall is changing. Well, first of all, can you picture it? Can you draw a diagram? Well, that is the diagram I have drawn for you. That's the wall, that's the ladder. The angle between the wall and the ladder is theta, and the height of the wall from the base to the point where the ladder is touching the wall is y, and this length is x. The length of the ladder is a constant, that is 8 meters. Well, you have a lot of information in there. Alright. Now, the base of the ladder is at a distance x from the wall, and the base is pulled at the rate of 0.6 meters per second mean. What does it mean? The base is pulled at a rate of 0.6 meters per second means dx by dt is 0.6 meters per second. And this dx by dt has this value when x equal to 3. Well, when x equal to 3, then you can find the value of y at that time if you need it. Is that right? When x equal to 3 and the hypotenuse is 8, you can find the value of y. X squared plus y squared equal to 8 squared, and at when x equal to 3 and the length of the ladder is 8, we can find the value of y. Now, what are we looking for? We are looking for d theta by dt. What is the rate at which the angle is changing? Well, in order to find the rate at which the angle is changing, you need to establish a relation between the known and the unknown so that we can find the unknown. Well, we know x and the rate at which x is changing. We know the length of the ladder. Can you give me a relation connecting theta, x, and the length of the ladder? All right, I'm going to wait for 5 seconds. Did you get the relation? This is a right triangle, and this is an acute angle. X is the opposite side. The length of the ladder is the hypotenuse. So sine of angle theta is x over 8. Is that right? Yes. So, we got, now obtain a relation connecting x theta and 8 from the figure. We got sine theta equal to x over 8. What we need to do is to find d theta by dt when x is changing at the given rate. So what all now we need to do is find the derivative of both sides with respect to t. That's right. So find the derivative of both sides with respect to t. What is the derivative of sine theta with respect to t? Now I'm repeating this several times because I know at least one of you will have problem figuring it out. The derivative of sine theta with respect to theta is cos theta. The derivative of sine x with respect to x is cos x. The derivative of sine theta with respect to t is cos theta times d theta by dt. So, derivative of sine theta with respect to t equal to derivative of x over 8 with respect to t. Alright, the derivative of sine theta with respect to t is cos theta d theta by dt. Tell me, what is the derivative of x over 8 with respect to t? I know when you see this, some of you will say this is a quotient. But remember, 8 is a constant. So this is the same as 1/8 x. 1/8 is a constant. And so the derivative of x over 8 with respect to t is 1 over 8 times dx by dt. So cos theta d theta by dt is 1 over 8 dx by dt. Well, we need to find d theta by dt. So solve for d theta by dt from there. And also, if you want to find d theta by dt, you need the value of cos theta. Is that right? Cos theta from the triangle is adjacent side divided by the hypotenuse. Do we know the adjacent side? We can find the adjacent side from that relation, x squared plus y squared equal to 8 squared. So, we would say cos theta equal to y over 8. And y can be calculated, or didn't we do that? X squared plus y squared equal to 64. When x equal to 3, x squared is 9. So y squared is 64 minus 9, which is 55. Therefore, y equal to square root of 55. That gives you cos theta equal to adjacent side divided by hypotenuse. Y divided by 8, that is square root 55 divided by 8. So, we have the value of cos theta, we have the value of dx by dt, and therefore d theta by dt equal to, divide both sides by cos theta, you get 1 over cos theta times 1 over 8 dx by dt, and that will be 1 over cos theta. If cos theta is square root 55 over 8, 1 over cos theta is 8 over square root 55 times 1 over 8 times dx by dt is given to be 0.6 meter per second. And that is 0.08 radian per second. The rate at which the angle changes is measured in radian per second. Alright, now I want you to do this on your own. All edges of the cube are increasing at the rate of 2 centimeters per second. Well, of course, the cube has all its sides equal. Now, how fast is its volume increasing when the length of each edge is 4 centimeters? It's a very simple one. Try that and let me know if you need any help.